This flip learning video is on static rigid bodies. It's one of the A-level maths units, and you are going to be researching static rigid bodies. It's one of the applied topics. So first of all, we're going to go through the concept of a static rigid body. Now, in physical science of dynamics, the rigid body dynamics studies the movement of systems of interconnected bodies under the action of external forces. So the external force may be gravity, it may be some sort of mass that's placed on it. And the dynamics of a rigid body is described by the laws of kinematics and the action of Newton's second law of kinetics or other derivative form in Lagrangian mechanics. We're really going to be focusing on rigid bodies which are in equilibrium, so they're not moving, and you're going to be looking at and researching about resolving forces in a horizontal and vertical direction, and why we might need to do that is something's in equilibrium and what that's going to tell you about the forces, and also by researching about taking moments and why we might need to take moments and where might be an appropriate point to take moments from to minimize the number of unknowns. And these are important questions to answer. So an example might be when a manufacturer designs a ladder and needs to decide what is the maximum or minimum angle the ladder needs to make with the wall to ensure that it's as stable as possible when somebody is standing on the ladder. So you might want to go away and find out some more about that, and maybe you look at some ladders online and have a look at the labels that come with them, the information that come with them, and look at the angles, what they tell you about the angle at which the ladder needs to be placed against the wall for it to be safe, and also maybe the maximum weight that is allowed on that ladder. Okay, so here's an example type question to help you on your way to research this flipped learning activity. So you've already learnt about resolving forces, and resolving forces by taking horizontal and vertical components, or components which are parallel or perpendicular to the plane or the direction that you're interested in, and also taking moments. And if you haven't learnt about taking moments yet, now's your opportunity to do a bit of research and find out about moments. You could even use Hind's Maths to help you. Now you'll need to know both of these and use both of these if we're going to solve static rigid problems. Here's an example question. So we have a ladder AB of mass M, and its length is 3a. You can see that A plus 3a there. And end A is resting on rough horizontal ground, so you need to think about the forces there. Anytime a body is in contact with a surface, we're expecting a normal reaction. Think about which way the ladder wants to slide at the bottom here and which way the frictional force will go. So there should be two forces acting at this point. Think about them. The other end B rests against a smooth horizontal wall. So if it's a smooth wall, there shouldn't be any frictional force here, but there is still a normal reaction because this body is in contact with a flat surface, with a plane. It doesn't need to be a flat surface, but when two bodies are in contact with each other, you always get this normal reaction. A load of mass 2m is fixed at the ladder at point C. So here we're going to have a mass going down, and this mass is 2m. And AC here, this distance here is A. The ladder is modelled as a uniform rod. Now, if it's a uniform rod, that is going to tell you something about where the mass of the ladder is going to be acting. Again, something else for you to research. In a vertical plane perpendicular to the wall, and the load is modelled as a particle. So these are all things that we know, but it'd be good to remind yourself, okay, what does it mean by being modelled as a particle? The ladder rests in limiting equilibrium. So again, remind yourself about what limiting equilibrium is, at an angle of 60 degrees with the ground, and I can see that angle is here. And there are certain things we need to find: a coefficient of friction between the ladder and the ground. And then we need to talk about some assumptions about what we do when the ladder is uniform. I'll leave you to find all of these things out for yourself. So, your flip learning task. Find out what a static rigid body is and examples where they might be used in engineering in particular. 2. In a presentation, that could be a PowerPoint or Google Slides, go for an exam question showing full working and any key points. Now, point number 3, your example should include the following: the directions you are going to resolve your forces in, which forces you need to find the components of, the point at which you're going to take moments from, and your reasons for taking moments from that point, your equations and your solving of them simultaneously, any equations you have made, and an appropriate rounding of answers, and why you may lose a mark for an exact answer. It's really important. Other examples you could investigate: static rigid bodies which are stationary, static rigid bodies where the resultant force in any direction is 0, static rigid bodies where the resultant moment is 0. So here's an example of where we might use static rigid bodies and moments and forces. So that's your task. And you know what, really looking forward to seeing your final outcomes, your presentation when you are back in the classroom. Good luck.